So just to review, from last class, I introduced you to two forms of a quadratic. So this was one of them. Orange for Halloween, I guess. I don't know why I think you. Let's go! First. And I asked you, were those the same equation?
Oh, yeah.
Were those the same equation?
Yeah.
Remember when we distributed this out? So let's do this real quick. So x minus 1 squared minus 9. X minus 1 squared minus 9. How can I expand that out?
Break it down into x minus 1, x minus 1, like in two different brackets.
Yeah, so x minus 1 times x minus 1 minus 9, which is...
Yeah, x squared minus x minus x minus plus 1.
Which is...
x squared minus 2x plus 8 minus 8.
Minus 8, which is the same thing as this, right?
Yeah. That seems correct, yes.
Alright, so do you remember what this form showed us? Remember we graphed it in Desmos?
Yes. It's a parabola, right?
And this didn't really tell us anything. But the other number at the end of it did.
That was the
Test me on a Friday? You want to have fun or so we can...
Ooh.
I bet mommy and daddy aren't going to come pick it up at the end of the day on Friday. That last number was the y-intercept. And then this created the vertex, right? It was very similar to absolute value, and that's why today's lesson is going to be so easy. What's the vertex of this parabola?
-1, -9.
What?
It's 1.
1, -9. You just took a snapshot over absolute value where you had to find the vertex, so...
Yeah.
I don't know.
You're so smart.
Oh! I think I got that wrong.
So, this is the first thing on your notes here at the top. So the first thing we're going to do there, this was kind of on your homework. We're going to graph a quadratic and kind of see why a quadratic looks like the way that it does. So here is our most basic quadratic equation.
It's the parent.
It's the parent function. We call it it's the most basic one. There's no transformations happening. There's nothing else going on. It's just where's the vertex at if it hasn't moved?
0.
0, 0, right? So just like our absolute value, if it has not been transformed, it starts at 0, 0. Okay? So let's throw some points on this and see kind of what we get. So it's always good to put in a couple negatives, 0, a couple positives. Because negative numbers act differently than positives, and 0 is always kind of weird sometimes, does weird things. So if we just get a little bit of each. And now all we're going to do, we're just going to take each of these x values and we're going to square them. That's all. So a quadratic is really, you're just taking the x value and then squaring it. So what is -2 times itself?
4.
4. What is -1 squared? Positive 1. 0. 1.
2. 4.
4. So obviously we already knew we were going to have 0, 0. That was the vertex. But now kind of the part that is a little bit different. We have the point 1, 1. And we also have the point -1, 1. Because what happens when you square a negative number? So even though the x value is negative, because our x values that are negative are over here, we have a positive 1 output. Left 1, up 1. Now that looks, so far, that looks the same as absolute value, right?
Yes, sir.
So if this was an absolute value, let's pretend, so this was an absolute value of x, we'd start at 0, 0, and then we'd go up 1 over 1, and we'd keep doing that, right? Feel like it had a slope of 1, it would keep going straight. But we've already kind of seen on Desmos, a quadratic is not a straight line. It's curved. So, let's put these through. So if we put these other points on here, so we have 0, 0, we have negative 1, 1, 1, 1. If you graph over 2 up 4, you can see that that is not on a straight line with the 0.11. And negative 2, positive 4. What do you think would happen if we plugged in, or what would we get if we put in 3?
It's 9.
9. So over 3 up 9. What about negative 3?
Same thing. It'd be negative 3.
On the other
It would also be positive 9, right? Up 9.
Parabellum.
What about 4?
It'd be 416.
5.
25.
Yeah, these are perfect squares, right? We're
Yeah.
squaring them. Okay. So you can kind of see this is not a straight line. So you're going to see this in a little bit. What is my a value here? What number is in front of x squared?
1.
1. We know, what if the a value is negative? What's that going to do to my parabola?
Makes it flip it.
It's going to flip it upside down.
Horizontally.
But remember, we can graph the a value kind of like slope, right? But what happens? Does that work with a parabola? Can I just keep going up 1 over 1, up 1 over 1, up 1 over 1? No, you can only do it one time. So the a value does work one time, but then from there it curves. So kind of our final parabola shape is kind of that U-shaped parabola.
Hey, you.
Okay, so here's just some features we've seen. X-intercepts, we know what those are. So x-intercept, we've seen y-intercepts before. We know the change from decreasing to increasing is called the vertex. The new word you're going to use today,
Axis of symmetry.
and I think I introduced this to you last class,
Yes.
the axis of symmetry.
I just said
Ooh, not teacher.
Also known as the line of symmetry, but for some reason someone wanted to make it sound really like villainy.
Axis.
So we're going to refer to it as the axis of symmetry, or the AOS, you'll hear me say. All that is, it's the line of symmetry, it's the mirror that cuts the parabola in half.
Oh.
That's all that is.
Oh.
So here is our vertex form. I don't know why it's defaulting orange. Here's our vertex form of a quadratic. Does that look familiar?
Yeah.
Yeah, that's really similar to absolute value. There's a couple differences. What's one of them?
It's square.
Cassidy, what's one of them? There's an exponent. We know that x has to be squared at some point to be a quadratic, right? So we have a square happening. What else?
It's not absolute value.
Yeah, instead of absolute value signs are parentheses. Other than that, our vertex form is almost identical. There's a couple things we're going to have to tweak, but for the most part, our vertex is HK. Okay? We'll talk more about this stuff here in a second. If A is positive, we know the parabola is going to open up, right? What happens if we throw a negative A?
Opens downwards.
The parabola is going to open down. It's going to look like a hill, right? We've seen that before. If A is greater than 1, it's stretched. That's no different. If A equals 1, that's our parent function. That means it's not dilated. It's normal, like up 1 over 1, up 1 over 1 with our absolute value. And lastly, if A is between 0 and 1, like 1/2 or 3/4, we say that it is compressed. All of that is the exact same. Okay? So let's compare. We have an absolute value. What is my A value? 2. What is my H value? You just did this snapshot.
4.
It's negative 4. What's my K value?
3.
Negative 3. Over here, I have a quadratic, and how do I know this is a quadratic?
Because
Parentheses squared. Okay. What is my A value?
2.
What is my H value? It's negative 4. This is not under notes. K is negative 3. So, what is the vertex of both of them?
Negative 4, negative 3.
Negative 4, negative 3. Negative 4, negative 3. That is the same. Now, what is the A value? 2. What does that mean?
That's the slope.
Now, slope, that's good. We're going to stop using the word slope, though. Slope is referring to a straight line. So that's okay for absolute value. So if we have a slope here, up 2 over 1, up 2 over 1, right?
Oh.
But that's only if it's a straight line. Slope is constant. So that's what we did on your snapshot you just took, right?
Yes.
You can still go over 1, up 2, but you can only do it once. Because after that, it's going to start curving in. It's not, you can't keep going up 2 over 1, up 2 over 1. It's going to, or up 2, whatever, over 1, up 2. Because it's going to be a straight line. So I'll show you more how to do that in a little bit. But basically, you can kind of see a lot of what we're doing today is going to be very similar. Okay? So let's apply this to, we got 4 examples today and we're done. So here's example 1. What is A? Let's just write it at the top here. What is A?
3.5.
1/2. What is H?
2.
Positive 2. And K is
They have a board.
4. So we know this is going to go right 2 and up 4. That's your vertex. So go ahead and graph your vertex. Right 2, up 4. What does my A value tell me? Is it going to be stretched or compressed? If you forgot, don't just guess. Look at the notes right above there. It tells you. It's compressed. It's going to be a little bit flatter or wider than a normal parabola. So all of that still works. Okay, so our vertex, I know I didn't put this on your notes, but you can write it down under if you want. So vertex is 2, 4. We've already determined that. The axis of symmetry is the line that goes down the middle of the parabola. So where would that be? Now that we know the vertex, it would be 2, right? We write it as a vertical line, so x equals 2. Always write x equals whatever x value it is. Now you actually need to graph that. That's part of the graph. On a test, I would assume or expect you to graph that, and we typically do it with a dotted line. So the AOS goes right down through the middle of the vertex. Okay, what is my A value?
1/2.
It's 1/2, good. What is that? So it's compressed. If that was a straight line, how would we graph a slope of 1/2? Up 1 over 2, right? It's a little bit different with a parabola. We're not going to go up 1 over 2 anymore. We're always going to go over 1, over 1, and then up or down the A value. I'm just going to write all my notes in dotted lines from now on. So what I mean by that, watch this. This is very important. This is the main difference. Start at the vertex. Everyone put your pencil on the vertex. Go over 1, and then what's my A value?
1/2.
So that means you go up 1/2 of a box.
2.
It's a little bit different, but I'll show you why. It's really obvious why the other way doesn't work in just a second. So once again, you're going to go left 1, up 1/2. So what if it was a 4th? What would you do? Over 1, up 1/4 of a box. Does that make sense? What if it was a 7? Over 1, up 7. That's the same, okay? Now the next thing, really the only new thing to us, I'll put this on the TV real quick, is the y-intercept. Okay? So, let's look at a xy axis real quick. If I'm on the y-axis, these colors are ugly. What is this point?
1, 0.
0, 1, right?
Yeah.
What is this point?
0, 0.
Middle 0, 1.
0, 4. 0, 5.
What is x when I'm on the y-axis?
0.
It's 0. It's always 0.
So it's a 0.
So watch what we're going to do here. If I want, I'm going to erase all this so you're not confused for a second. I'm going to get rid of all this. If I'm trying to find the y-intercept, you plug in x equals 0. We know if we're on the y-axis, you're going to plug in x equals 0. So what that's going to look like, take the original function, which is 1/2 times 0 minus 2 squared plus 4. Interesting. Very interesting. Now, if you want to, I'm okay with you just throwing this whole thing in your calculator. If you want to simplify it old school, you can, but I just type it in, so 0.5, just short for 1/2, right? 0 minus 2 squared plus 4.